Hey everyone, Blockchain Bernie here, episode 315, and this one is about L2s versus extensions. All right, so you might want to think, well, what the hell is that? And an L2 is a layer 2. I know what a layer 2 is. It's kind of a scaling solution, but what is an extension, right? So an L2 in the classic sense of the word means it is a layer 2 solution, usually kind of a roll-up. That's the technology there. And that means the layer 2 is batching transactions, right? So the L2's purpose is mostly to do the transaction processing faster and cheaper, and then only at regular intervals use the security layer of the underlying blockchain. And then L2s are especially popular on Ethereum, of course, use the underlying blockchain to use the security layer, right? So those are L2s, right? L2s means batching transactions. So every transaction you send to the L2 will be processed in the L2 in the layer 2 blockchain first, and then will be batched. And then there's different ways of, syncing them back to the underlying blockchain. There's ZK rollups, there's optimistic rollups, and lots of differences between the different types out there. But all the L2s have that in common. They are batching transactions because executing each transaction on the underlying blockchain, in the case of Ethereum, is relatively slow and relatively expensive. So that's why these L2s are there. So what is an extension? On the contrary, and many people are not that familiar with that. And what we're building here at Xandeum is an extension to the Solana blockchain, extending it with a storage layer that's readily available to smart contract developers, to Web3 devs, right? And in addition to Solana accounts, they have those Xandeum buckets for themselves, which is a huge file system, right? It's not just an object store, it's a huge file system. You can compare it with a Unix file system, or what you have on Windows or anything. Those are all file systems with directories and files, and you can delete those files and rename them, and you can overwrite some parts in the middle of the file, right? And programs can do that for you. So that's why databases like MySQL or stuff, they all live in files mostly, because these files are random access and they are overwritable and deletable and all these kind of things. And that's what Xandeum is doing. And this functionality is there on the Solana chain, but only in Solana accounts. And the Solana accounts don't scale with regards to storage capacity. You cannot even store gigabytes, let alone terabytes in there. And for successful Web2 apps, you all have that kind of storage capacity. So we're adding that missing storage layer to the Solana blockchain as an extension, right? An extension means it's just adding functionality to the existing blockchain. And are there other examples of extensions? Think, for example, of Jito, right? Jito is adding MEV functionality to the Solana blockchain, right? And it's really deeply integrated into Solana. The Jito has their own Jito Solana validator software, their own validator client, as it's called in blockchain speak. And that Jito Solana client provides that extended functionality, and it helps with implementing the MEV, creating bundles, right, which is the core functionality of Jito, which means several transactions can be bundled together into one bundle. And then whoever wants to run them as a bundle has to pay a tip in order to get the validators to execute them atomically as one piece, right? So that means if the second transaction doesn't go through, the first one will be rolled back. And also the validators will guarantee that there's no other transactions in between the two that are combined into a bundle, right? Or it could be more than two as well. So yeah, Jito is extending the Solana functionality, and they are not an L2, right? They are not batching transactions. I mean, they're bundling them, but it's different from, but they are executed on the Solana chain, right? Each transaction is executed directly on the Solana chain. They are just reordering them, right, through that MEV thing. but they are not batching them, executing them only in an L2 and then at regular intervals, put them back on the Solana chain. They don't do that, right? They just extend the functionality of the Solana chain. So that's an example of an extension, right? And what we build at Xandeum with that storage layer, it's another Solana extension. It just adds more functionality to that Solana chain so that the devs, in the case of Jito, it is for searchers, right? Searchers are the guys that want to bundle transactions and want to have them executed without anything else coming in between. So they want to control the order in which transactions are being executed on the Solana chain. So in our case, what we make this for is for devs, right? It's for Web3 devs, startups that build Web3 dApps, decentralized apps that need a lot of storage in addition to the Solana accounts, right? So we're extending the functionality of Solana to have these storage accounts, which are like the files, right? In that metaphor, right? The Solana accounts are the RAM, and then we're adding instructions, we're adding new primitives that are being understood by our modified RPC software, so that the devs can take data that's in a Solana account and copy it out into a file, right? It's into one of our Xandeum buckets, how we call them. And then at a later point in time, they can read them back, and then they will be copied back into the Solana accounts, right? And this whole storage on this second tier of storage is offloaded to our own set of PNodes, storage provider nodes. There are way more of these storage provider nodes out there because all they do is store. They don't need a lot of CPU. They don't need a lot of RAM. They just need good and fast storage and good and fast internet connection in order to return that stuff fast. But obviously, since stuff is being copied from the storage layer into the accounts and back, they're a little bit slower than the accounts themselves, right? It's just with the normal computer. If you need something fast, you do it in RAM. But if you have a lot of capacity, you need to offload it to a slightly slower medium, like an SSD, and store it there, and then copy it back and forth between the high capacity storage medium and the RAM, right? So I think this metaphor comparing the blockchain, the smart contract blockchain, with one giant world computer is a very, very nice metaphor. And then you using that metaphor, you will see immediately that today's blockchain, smart contract chains, they have that CPU. They can all execute codes, whether it's on the SVM, the Solana virtual machine, in Rust, and compiled into some intermediate code, or whether it's on the EVM and the Ethereum virtual machine and all these things, right? So all those smart contract chains, and it started with Ethereum in 2015, they can execute code, and they all have that RAM in the form of accounts. So Solana has Solana accounts, Ethereum has Ethereum accounts, but there is no storage that is part of that whole thing, right? All the storage we have is completely separated. It's not part of the smart contract chains. It's not smart contract native. And that's why we here at Xandeum are so obsessed about that blockchain storage trilemma, right? It means we want to have it smart contract native as the accounts are, right? Because we're looking for something for devs to be able to use when they write apps, right? We're not looking for something that's outside of that smart contract world, right? It needs to be smart contract native. And then it needs to be random access, right? Because only random access gives us the primitives to build all sorts of apps on there, right? So we're not looking for something that just archives data, or something like, block stores like Amazon S3 with their buckets. You can just write a complete object, which can be large. It can be gigabytes. But then you can't overwrite it in the middle. That would create a new object, which makes things slow and stuff like that, right? It's not a random access thing. So we needed smart contract native and random access just as the accounts are, right? Plus, we needed scalable to exabytes and more, right? And that's what we're doing by creating that additional tier of storage, in addition to the accounts, and offloading of storing the actual data from the validators to a separate network of PNodes. And once it's all up and running, it can be tens of thousands, hundreds of thousands of PNodes out there. And that all needs to scale to this number of PNodes. And the PNodes are being supervised by the validator, by a special validator software that is doing all that. And yeah, we couldn't be more excited about building all that stuff. So, but that is an extension, right? So that was the point of this video. What's the difference between an L2 and an extension? So we're building this as an extension. We're being asked so often, are you an L2 of Solana? No, we're not an L2, right? We're not batching transactions. We're just extending the functionality, and hope that difference has become clear in this little video. If it did, please destroy that like button for me. It really helps us, helps the YouTube algorithm, gets our content out to more people. And for today, thanks so much for watching. Catch you later, guys. Peace.